morning to all my students. I am here to conduct our third session. In the previous two sessions, the topic that we covered were computational thinking and Sudoku. I hope everyone has understood and can relate to what was discussed through the sessions. And I even hope the previous session have helped you all to complete your exercises that was shared by me in our last session. So moving forward, today I am here to discuss about the new chapter, that is searching and sorting techniques. To make it easy for everyone, I am going to discuss this chapter in parts. The first part that we are going to discuss is searching. Children, do you know how data is searched in computers? Let's learn about it in this chapter. Any search is said to be successful or unsuccessful depending upon whether the element that is being searched is found or not. So, searching is an operation or any technique that helps to find the location of an element. I repeat again, searching is an operation or any technique that helps to find the location of an element. So, by the end of this session, you will be able to identify and understand some standard searching techniques. There are two types of search techniques which we are going to handle or focus on. First is linear search, second binary search. So let's start with linear search, which is also called as sequential search or line-wise search. This is the simplest method for searching. As the name suggests, sequential search is made over all the elements one by one. Every element is checked, and if a match is found, then that particular element is printed. Else, the search continues till the end of the list. Linear search can be performed on a sorted or an unsorted list. Let's see a presentation which will enable us to understand the linear search in an unsorted array in a step-by-step animation. So, suppose we have an array. As we said, we are going to see the linear search in unsorted array. What is an array? An array is a collection of elements of same data type. Each element identified by an index. Index starts from 0 till the end of the array incremented by 1. So here the array is A of size 10 elements. That is A of 0 starts with 0 and then ends with A of 9. Suppose the data that is to be searched is 57. So, how will we do using linear search? So first, we compare the first element, that is A of 0, with 57. Here, A of 0 is 11. That means data is not found. Then we increment the index to A of 1. Comparing A of 1 A of 1 is 2. 2 is not equal to 57. That is data not found. Again, the increment is done to A of 2. A of 2 is 9. 9 equal to 57? No. That means data not found as A of 2 is 9. Increment the index to A of 3. A of 3, that is 13 with 57. Data not found again. Thus, incrementing the index to A of 4. Comparing A of 4 with 57. Here, as you can see, data found as A of 4 is 57. This is how the linear search is done and the searching is successful. This was about the unsorted list. In case of sorted list, here too the searching starts from the first element and continues until the element is found or till the element greater than the value being searched is reached. Let us see a video which will give you a good picture of linear search.
Suppose we have the array like which contains the element 3, 8, 2, 5, 6, 7, 4 and lastly 1. And suppose our search element is number 7. So we'll compare 7 with all the other elements in our array. So the first element will be number 3 as it is on the first position. So now after comparing the first element, we found out that the element is not equal to 7. So we will remove that element. And after that element, we'll go to the next element. Again, we'll compare our key element and the second element. Again, it's not equal, so we will remove that. Same thing we will do with the third element, that's number 2. And number 2 is again not equal to 7, so we will again remove that 2. Then we will do that same with 5, the next element. And again 5 is not equal to 7, so we will remove it. This process continues until you found the search element or you found the end of the array. So now with 6, again it's not equal to 7, so we will remove the 6. Now comes the seventh element. And as you know, 7 is equal to 7, so we found our search element and our search stops. So in the linear search, what happens, we will compare with all the elements one by one. First we will search the first element, then with the second, third, fourth. Likewise, if you have n numbers, it will search for n times unless and until the search element, in this case it's number 7, is found. So this is how linear search works. In the next tutorial, I will show you.
Now, let us see the algorithm of linear search. Here, the algorithm starts with an array or list of numbers. Here, A is the array or the list of numbers, that is 10, 1, 9, 11, 46 and 24. X be the value to be found or searched, that is here X is equal to 11. I be the index of the list. Index means the element number on the array. Here I can see 1, 2, 3, 4, 5, 6. And n be the total count of the numbers in the list. Here n equal to 6. That is the size of the array. So let's start with the algorithm. Algorithm starts with step 1. Set I equal to 1. That is the first element. I equal to 1. Step 2. If I greater than n. 1 greater than 6. Is it true? No. If it was true, that means it has reached the end of the array. So here it's the first element. So it has not reached the end of the list. So we go to the step 3. If a of I equal to x, that is a of I, a of 1 is 10. Is 10 equal to 11? No. Go to step 4. Step 4 increments the I value with plus 1. That is, I becomes 2. As we didn't get our value, there is a repetition or a loop. Step 5 tells us to go back to the step 2, where again I is compared to n. Is I is 2. 2 greater than 6? No. Go to step 3. A of 2 is equal to 1. Is 1 equal to 11? No. Increment I to next plus 1, that is 3. I becomes 3 now. Go to step 2 again. Is 3 greater than 6? No. Step 3. If a of 3, that is 9. 9 is equal to 11? No. So, set I equal to I plus 1, that is 4. I became 4. Again we check. Go to step 2. If I greater than n, that is 4 greater than 6, have we reached the end of the list? No. Step 3. If a of 4, that is 11. A of 4 is 11. Is a of 4 equal to x? 11 equal to 11? Yes. So if this is true, go to step 6. Step 6 tells us that we found the element and the index is 4. Then go to step 8. This is how the algorithm of linear search works. We have done the hand running of the algorithm. With this, I hope everyone have understood the linear search. Now, so the linear search is simple and do not require the array to be sorted. But as we saw, it is time consuming as it has to go through the entire list one by one. Now, moving on to the binary search. Here, the word binary means made up of two things. As the word says, in this method, the list is divided into two parts. One from 0th element to the middle element, that is the first half. Other from the center element to the last element, which will be the second half. Before the list is divided, the list need to be in a sorted order. This is a very important point, that is, in binary search, the list has to be in a sorted order. The searching mechanism proceeds depending upon whether the target element is greater or smaller than the central element. That is, if the element is smaller than the central element, then the searching is done in the first half and the second half is ignored. Whereas, if the element is greater than the central element, then the searching is done in the second half. For our better understanding, let us see a video which will explain the binary search in detail.
Binary search algorithm searches for an element in an ordered list using a process in which at every step of the algorithm the list remaining to be searched gets divided by half. That is, if the element for which we are searching is not found. For this example, we'll be searching in a 13-member list with index ranging from 0 to 12. So we'll be searching for the element 201, or rather number 201, which we'll be searching using binary search. So let's define our lows and highs pointers. So in this case we have the whole list, and the low pointer is at 0 and high pointer is at 12. And remember, this is a sorted list. One of the primary criteria of using binary search on a list is that the list should be in sorted order. So now to find the mid element, we do 0 plus 12.
So to find the middle element, we add the low and high, then divide by 2, which will give us the middle element, that is the sixth element. 12 divided by 2 is 6. So sixth element is 101.
The indexes of low and high added together by 2, which gives us mid at 6. The element at 6 position, or the mid position, is 101. Now we need to determine whether the mid element is less than, equal to, or greater than the number we are searching. So first we compare with equals. In case we have already found the number, then we can stop searching at this point. So we compare 101 to 201, and we find that 201 is greater than 101. So this brings us to an important conclusion, that since 201 is greater than 101, which is the midpoint, and the list being in sorted order, so all the numbers before and including the midpoint will all be smaller than 101 or equal to 101. Since our number which we are searching, 201, is greater than 101, so it will not be for sure found in the locations prior to or equal to mid. Since our number which we are searching, 201, is greater than 101, so it will not be for sure found in the locations prior to or equal to mid. So keeping that in mind, we can effectively ignore the list till the midpoint. Now, ignoring the list till the midpoint in our case is simply moving the low pointer to the position mid plus 1, that is to the point from where we can have the number 201, and the high pointer remains where it is. So now our low index becomes 7 and our high index becomes 12. Now we again find mid value, which will be 7 plus 12 by 2, or 19 by 2, which is 9. Ninth index contains the number 179. We again follow the same comparison process, and we see that 179 is not the number we are searching for, and so we see if the number we are searching for is greater than 179, and it is indeed greater than 179. So what we do is we again follow the same process, and we discard off, or rather ignore, all the elements less than or equal to 179 at index 9, and so we move the low index to mid plus 1 position, which is 10. So our low now moves to 10 and our high is at 12. So we now have low at 10, high at 12. We find its average, which is the mid position, and mid comes out to be at 11. Now we again compare the number at mid position, that is 356, with 201, and we find out that 201 is less than 356 this time. So that means all the elements at index 11 and higher are of no use to us because they are all greater than 201. So now what we do is we move the high pointer this time to mid -1 position, which is nothing but 10th position. So our high is at 10th position, our low is at 10th position itself, and our mid also is at the 10th position. So now we compare the element at mid with 201, and it is indeed the element we are searching for. And so this is how we find 201 using binary search.
Let us now see the algorithm for the binary search. In the screen, you can see the algorithm and a picture of how to search an 10 element array using binary search. Here, in the example, we have an array of 10 elements wherein the element to be searched is 23. This is right here. So let A be the array. This array name is A. X be the value, that is X is 23. I the index, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. N be the total count, N is equal to 10. And LOC is the location of the value to be found. Beginning of the array is called lower bound, that is, we are showing it as L here. And the end of the array is the upper bound or the higher bound. Here we are showing it as H, okay, upper bound or UP. According to the algorithm, step 1, we set I equal to 1. I equal to 1. Step 2, set the beginning, that is L, and end to LB and UP. And mid is calculated as lower bound plus upper bound divided by 2, as you have seen in the video. Go to step 3. As we do that step 2, we get the mid, that is 16. Step 3, we compare. If the lower bound is less than equal to the upper bound and the A of mid equal to X. That is, we are checking if we have reached the end of the array and also if we have got the mid as our element. Go to step 4. Here the comparison is done. The comparison is done between 16 with 23. Here we check if 23 is less than 16. So no. So the lower bound is shifted toward mid plus 1 as 23 is greater than 16. So second half will be considered and the first half will be ignored. As we can see in the picture, the first half is taken out, the second half is considered now. Now the lower bound is made as mid plus 1, that is 23 here, and the higher will remain the same. The mid got changed. Here the lower becomes the 6th element and the higher remains where it was. Again, we find the mid of this array, that is 6 plus 10 divided by 2. 16 divided by 2 is 8. 8th element we have 56. Now this A of 8, we have to compare it with our element, that is 56 with 23. So we have 56 is greater than 23. So the elements above 56, that is elements from 8, 9, 10, these elements are ignored, and our array which we get is 6 and 7 elements. Again, we find the mid of the elements, that is 6 plus 7 divided by 2. So we get 6, that is 23. Here we check the step number 3, that is A of 6, that is 23, equal to 23, true. That means we got our element and we exit. Students, for your notice, I would just let you know that these algorithms need not to be remembered. You just need to know the procedure, how we search using linear as well as binary search. With this, I hope binary search is clear to all. So the binary search is not time consuming, but the only condition is the list must be sorted. That is the only condition given by the binary search. So the major difference between the two, linear search and binary search, is first, input data needs to be sorted in binary search and it may not be sorted in linear search. Second, linear search does the sequential access. It goes from one by one, whereas binary search access data randomly. So, as the conclusion of our first part of the chapter and this video, that is searching techniques, what did we learn? So to end, linear search or sequential search is the simplest method for searching. In this type of search, a sequential search is made over all the elements one by one. This method can be performed on a sorted or an unsorted list. Binary search requires the list to be in sorted order. In this method, the list is divided into two parts. The searching mechanism proceeds from either of the two halves depending upon whether the target element is greater or smaller than the central element. So students, just to retrospect your understanding of this chapter, I am sending a quiz across as a Google form. You can see the link which is written on my notepad. So this link I'll be sending along with the mail. Kindly click the link and submit your answers. This will be evaluated as the first assignment. Hope to see you all soon. Signing off. Stay home and